Lesson 2.3.1 Introduction to Systems of Equations. In this video, we will solve systems using systems of equations by substitution and identify the systems as consistent or inconsistent. Alright, so the steps for substitution method. Step 1, solve one of the equations for one variable. I'm going to tell you that this step is, for the most part, not going to be needed. And we'll talk about it more later. Step 2 is substitution. You're going to substitute the expression from step 1 into another equation. Step 3 is to solve the remaining variable. Step 4 is to substitute the results from step 2 into the equation from step 1 and solve. And then step 5 is to write your answer as an ordered pair. Alright, so let's see these steps in action. Solve each system of equations by substitution. Determine whether the system is consistent or inconsistent. So if you remember in the first video, we defined consistent as having one or more solutions. We defined inconsistent as having no solutions. So that's what we mean by consistent and inconsistent. All right, number 3, we have 8x plus 2y equals 14, and we have y equals negative 2x plus 11. So our goal is to have one variable by itself. So we don't need to solve for the variable because it's already done for us. So that was our step 1 right there, and it's already done. So step 2 is to substitute this for y. So I'm going to rewrite the first equation, 8x minus 2, and then I'm going to leave a space right here. I'll move this over so I have more room. I'm going to leave a space right here and finish writing out the equation, so 14. And in that space, I'm going to take and put in that negative 2x plus 11. I'm going to substitute that in place of the y. Now we're going to solve for x. To solve for x, I first have to distribute the negative 2. So bring down that 8x. Negative 2 times negative 2x is positive 4x. We're going to take the negative 2 times 11 and get negative 22 and bring down that equals 14. Now I'm going to combine the like terms here, so 8x from 4x is 12x. Bring down the rest of it. And then we're going to add the 22 to both sides. And so we get 12x equals 36. And then to finish this, we'll take and divide by 12. So that the x is by itself, and we get x equals 3. So this is step 3 to do all this work here. Step 4 is to take our answer here and plug it into the equation up here. The y equals. You can plug it into either one, but y equals is a lot easier to use than the other one. So we have negative 2 times 3 plus 11. So negative 2 times 3 is negative 6. And then negative 6 plus 11, or 11 minus 6, is 5. And then the final step is to take and write our answer as an ordered pair. So x is 3 and y is 5. And that's our final answer. You can always check to make sure you got the correct answer by plugging it into the equation that you didn't use. And so you could say 3 times 8 is 24, 5 times negative 2 is negative 10, so 24 minus 10 is 14, and it works. So what I'd like you to do now is number 4 on your own, and then, oh, actually I lied. Since we have one solution, we would call this consistent. Okay, now I want you to do number 4 on your own. So go ahead and try it now. All right, so hopefully you noticed that the second equation was already solved for y. So we rewrote the first equation and plugged in for y the 2x minus 7. Then we went ahead and distributed and got the 6x minus 21. We combined the 6x with the other 6x and got 12x. And then we're going to add the 21 to both sides. Then we get 48 and we divide both sides by 12 and get 4. We take the 4 and plug it back into the second equation in for x, and we get 8 minus 7 equals 1. And so our ordered pair is 4, 1. And that's how you solve using substitution.